Radhe Radhe. Today's lead code problem of the day is rearranging fruits, which is marked as hard, which is not really the case. If we see three examples apart from what the sample is given, it will make things easy and you can code it up on yourself. So what the problem specifies is you are given two baskets and the task is to make both the basket equal. By equal, what it means is two baskets are considered equal if sorting them according to the fruit cost makes them exactly the same. And how the cost is calculated for swapping is when you swap one element from basket 1 to basket 2. So whatever is the minimum of these two elements, that will be our cost. So our task is to minimize the cost and make both the arrays equal in terms like when it will get sorted it will be equal, which means like the frequency of each of the element in basket 1 has to be same with the frequency of each of the elements in basket 2, which let's see the example which will make things more clear. We'll take first these two sample examples and then few more examples which will make things clear. So the first example given to us was 422. This is basket 1, which is 4222, and basket 2 is 1412. So if it is sorted, then this will look like triple two and 4, and basket 2 will look like 1124. So we see this is equal, this is already equal. So only these two are different. So if we swap any one of the element, if we swap these two, so both the array will become equal. And the cost incurred to do will be the minimum of 1 and 2, which is 1. So finally it will look like and we don't need to sort it. It is just that while comparing internally it will be like sorted and checked whether both of them are equal or not. So yeah, here the cost would be 1, which is minimum of 2 and 1 which we swapped. Let us look at the second example. The second example was something like 2341. This is our basket 1. The basket 2 is 3251. 3251. Okay. Here, if it is sorted, so basket 1 will look like 1, 2, 3, 4, and basket 2 will look like 1, 2, 3, 5. So 4 and 5 is different, but it is impossible for us to make these two baskets equal. So in that case, we will return -1. So one observation is if any of the element, if any of the element is present odd number of times, in that case, we cannot make the baskets equal. So that's the first conclusion. Conclusion 1 is if some of frequency of elements of any of the element is odd, then simply return -1. This is our first conclusion. Next, uh, it's very trivial, but I'll just go through it. Like we've already said, like it's if basket one, let's say, is 1, 3, and basket two is 2, 2. So these sums up to 4, but they won't be considered equal. Reason is already given, like they'll sort and check, and elements are not equal. And our conclusion one holds here as well. Like if you see 1 is present odd number of time, 3 is present odd number of time. So we can, as soon as we, after parsing both basket 1 and basket 2, we observe like, okay, this is odd number of times, return -1. It's pretty simple. Uh, let's see few interesting examples which will help us make this problem from hard to easy. Okay, so example number 3. So first one from our side, the initial one was just to explain the question. So this example, let's say basket 1 is having cost as 3, 3 and 200 and 200. Basket 2 is having cost as, let's say, 4, 4 and 300 and 300. Now, so it looks pretty easy that what we can do is we can swap this 3 with 4, or the first one, whatever looks like. So we need to swap one this 3 and 4, and one 200 and 300. So if we swap this 3 and 4, the minimum is 3 here, the cost of swapping. And if we swap these two, so minimum is 200 here. So it seems like the cost would be 203 for making these two baskets equal. But this is not the case, because see, our ultimate goal is basket 1 should start looking like 3, 4, 300 and 200, and basket 2 should look like 4, 300, 4, 3, 200 and 300. But swapping with which element you have to do that, okay, my screen is this, yeah, but swapping with which element you need to, that is not fixed, right? So it's possible, see, you can swap this 3 with 300, so the minimum will be 3, and you'll get 300 on basket 1 and 3 in basket 2. Similarly, if you swap these two, so you'll get 200 in basket 2 and 4 in basket 1, which will be this configuration, and the cost will be 3 plus 4, which is 7. So we need to achieve the final goal, but swapping with which element you need to do, that is the task which we need to find out. Now, how will we know that we need to swap 3 with 300 or with 4 with 200? So the solution to this will be, like, whichever element you need to swap, you put it in a list, uh, and sort that list finally. Now what you can do is, after sorting, you can take the minimum element, which is the first element. Let's say you're starting from the first and traversing it. So taking the minimum element and swapping it with the maximum element, that will give you a minimum cost. Then move ahead. Go to the first index or the second element and second last element, swap that. So if we maintain a list, so this is our conclusion too. If we maintain a list and list of elements list of elements to be swapped. We maintain a list of elements to be swapped and sort this list finally, then pairing minimum element with maximum element will give us minimum cost. I hope points are clear till this line. Pairing or swapping. Okay, so this is our conclusion too. Let's take another example. So till now we have taken third example. Let's take a fourth example. Let's say our basket is having element 2, 7, 7 and basket 2 is having element 2, 8, 8. Now using conclusion 1 and conclusion 2. So if we use conclusion 1, so none of the element is present odd number of times if we sum up the frequency of element from basket 1 and basket 2. So conclusion 1 we saw and it is okay. We can proceed. Conclusion 2, like what elements need to be swapped. So we see 7 is present twice in basket 1 and it is not present in basket 2 at all. 8 is present in basket 2 twice, but it is not present in basket 1 at all. So 1 8 from basket 2 needs to go to basket 1 and 1 7 from basket 1 needs to come to basket 2. Using conclusion 2, we will create a list of elements that needs to be swapped. So it will be 7 and 8. Now if we swap 7 with 8, it gives a minimum swapping cost is 7. It turns out to be this would be the correct answer, but unfortunately this is not the right answer. Why and how is, if we have a global minimum, if we have a global minimum in looking at basket 1 and basket 2, if we have any global element which is less than any of the element which we need to swap, then we can leverage that element and swap it. How? I'll tell you. See, we can use this 2 to swap with 7, and when 2 comes on the basket 1, then we can again use 2 to swap with 8. It might be confusing. I'll show this step by step. So let's say first time what we did, we put swapped 7 and 2. So basket 1 will start looking like this and basket 2 will look like this. So 2 and 7 is swapped. A question may arise, like what if 2 was already in right place, we swapped 2. Now what if our process ends here, but what I will say is that this case is not possible at all, because you had to swap 7 and 8. Now you used 2 to swap 7, so only 7 has been swapped. Now when you try to put 8 in right place, you'll have to swap 2 once again. So earlier 7 and 8 was getting swapped. Now you are using a third auxiliary variable or auxiliary element to come in between that for help of swapping. So once 2 and 7 will be swapped, next time 7 and 2 and 8 will be swapped. So 2 will come back to its original basket. So that scenario will not happen, like, which might confuse few people. So yeah, this is our first step. Step 1, using 2 or using auxiliary element. Next time what we'll do is, again, what the 2 which we had put in basket 1, we'll bring it back using 8. So it will be something like 2, 8, 7, and 7, 2, and 8. Now if you sort it, this is the basket are equal, and the cost is, in step 1 for swapping 2 and 7, the cost was 2. Again on swapping 2 and 8, the cost become 2. So this arises only when we have a global minimum which is not present in the or even if it's present, it can be used. So if we have any global minimum, we need to take that into account, like if it is possible to use that and reduce the cost. So these were the final examples, but we'll see one or more two examples so that which can clarify our confusions, like when to use the auxiliary variables or where are the cases where this won't be used, and then we can code things up. So if you have understand till here, so these are basically the cases. Now if you want, you can try and code it up the solution. So this was example 4, I guess. Yeah. Now there can be a case, or we can try to code it up and see if something is confusing for us and I can get back here. So more or less these are the 4 example, and let me write conclusion as well. So conclusion 3 we will write uh, for calculating minimum cost, try to see if we can use global minimum as an auxiliary element. For calculating minimum cost, try to see if we can use global minimum as an auxiliary element to reduce the swapping cost. And you need to keep in mind, like when we are using auxiliary elements, so for swapping, let's say 7 and 8, 2 swipes were required. So minimum element into 2 will be required for a single swap. So for single swap, single original swap, this global minimum into 2 is required. I hope this point is clear. Now let's try to code things up, and if we get any confusion, we can get back to our tab. Uh, for frequency, we could have used array, but the element, if you see the constraint, the element can be 10 to the power 9. So if you use 10 to the power 9 in int in Java, 4 bytes, so it will be around 4 GB, which might crash. So we cannot use array here. So better to use a map to have the frequency. Word frequency map, fmap, new hash map, and we'll just scan through each of the element of basket 1. So we have parsed through basket 1, and for each of the element, we have added its frequency. Now let's go through the second basket. Let's say if this element was already seen in basket 1, then we will reduce the frequency by 1. If let's say there is an element which was not at all present in basket 1, but we encountered that in basket 2, so for that the frequency will be in negative. Like let's say 2 element was there, so it will store -2. And if let's say element was present twice in basket 1 and was also present twice in basket 2, so that will nullify, it will have 0. So yeah, this pretty much made up our frequency map. And now let's have a variable called as long answer as 0, and we need to have a global minimum as well. So let's make it as initial value would be integer dot max value. uh, now we will parse through each of the element of this frequency map which we have created. If the frequency is odd, then our conclusion 1 will come into picture. F map.get if frequency is odd, don't go anywhere further, just return -1 from here. But if that is not the case, other thing is it could be negative as well. So remember, like for basket 2 we kept decreasing, so it's possible that value will be negative, so we'll take absolute of that. And now yeah, so conclusion 1 is taken care. Now comes into picture conclusion 2. Like we need to keep adding it in one of the lists. So let's create a list of integer. We'll call it swap candidates. New list of Teacher. Hmm. If frequency is not zero, right? Because it's possible like frequency could have been zero, like for basket one, some frequency was there and same number of frequency was in basket two as well. So it nullified and now we don't need to do anything for that. So the thing is we need to see like if frequency is not zero, then only we'll do something and it will be like, and you remember like the number of element which is in access, we need to divide it by 2 and then distribute it to the other basket. So for equals 0 I is less than frequency by 2 I plus plus. And I'll tell you like why I am doing this is this frequency which is remaining will always have to be even, right? Because if it is not even, we've already taken care here. So uh, we are sure this will be divisible, so we'll get an even length of that candidates which needs to be swapped. So we can always map the first one with the last one, and there will be no odd elements at the between. So it will always have a pair. I hope this is clear. If not, I'll try to explain again in the tab because when we are swapping, it is always between two elements. It will never have single element which we want to swap. So yeah, I hope this should make things clear. We need to add this to swap candidates. Added this. So after this is done, we will selection start sort this one swap candidates. So now it is sorted. Now things come into picture like whether do you want to pair it up or the auxiliary element will help you. Now for auxiliary element, we wrote a variable here, but we never modified this. So let me modify this like after you have this. So min always be dot min of whatever current I have or whatever n is. So whichever is lower. Now, yeah. Now comes our conclusion 3. So conclusion 1, conclusion 2 we have already covered here in the code. Current I equals 0, I less than sub candidate size will go till by 2 only. I plus plus. Now, if swap candidates dot get of I, if this is less than equal to our global minimum into 2, then we will use this only, we will not use our global minimum. So in that case, our answer needs to be summed up with swap candidates dot get of I. We could have stored it one step earlier, not writing it multiple times. And if this is not the case, then we will use global minimum for 2 times. So our answer will increase by minimum into 2. This is pretty much the code if I haven't made any mistake here. Let us try to run this for sample. see. Okay, case 1, case 2, then so these are simple cases. What I would suggest is before submitting it, let's write up all our examples what I had shown in the video. So 1 and 2 are same. The other was 3 comma 3 comma 200 comma 200, and the other one was 4 comma 4 comma 300 comma 300, and next one was 277 277 288. Let's see if this works for these samples as well. It worked, so I'll hit submit. Cool, so it worked. Thank you guys. See you tomorrow.